Okay, in this video I'm going to derive the continuously compounded return formula using differential equations. So suppose at time t you have m amount of money in the bank, and a short while later, where the time is t plus delta t, you have m of t plus delta t. So the trick here is to expand m of t plus delta t using the Taylor series. So we would have m of t plus delta t equals m of t plus the first derivative of m plus times delta t plus the second derivative of m times delta t squared over 2 factorial plus the third derivative times delta t over 3 factorial, and so on. So we can ignore anything higher than the second derivative. So if we do that, we would end up with m of t plus delta t equals m of t plus the first derivative of m times delta t. If we subtract m of t from both sides, we would have m of t plus delta t subtract m of t equals the first derivative of m t times delta t. So the difference between the 2 points evaluated is simply m of the first derivative of m times delta t. And remember, this is proportional to r times m of t times delta t. Now what we can do is divide both sides by delta t. So we would have m of first derivative of mt equals r of mt. Another way we can rewrite this is as d of m over dt equals r m of t. Now this is just a separable differential equation. So what we do is divide both sides by m. So we would have 1 over m of t times dm, and we multiply both sides by dt, so we would end up with r times dt. Now we can integrate both sides. Okay, the integral of 1 over mt is ln of m, and the integral of r with respect to t is rt, and we have a constant as well. So now what we can do is take the exponential of both sides. So if we take the exponential of a log, we would have just mt, and the exponential of the right hand side is e to the rt plus c. And another way we can write this as m of t equals e to the rt times e to the c. So this is just a constant, so we can let that equal to a. So if we do that, we would have m of t equals a e to the rt. So now what we have to do is find out the value for a. So we have m of t equals a e to the rt. So we at time equals 0, we would have m of 0 equals a e to the 0. So m of 0 equals a. So we can substitute this back into this. So we would have m of t equals m of 0 e to the rt, where m of 0 is your principal amount, so this is a principal amount, and e of rt just a continuously compounded return.